Hi everyone, welcome to a Tess Academy YouTube video. This is part of our GCSE Maths revision lesson series where we will cover topics grade 7 to 9. Today we will run through the quadratic formula. Remember, if you have any queries, please visit our website at tessonlineschool.com. Also, please suggest any feedback, improvements or suggestions to us through the website. Thank you. The first thing we need to be aware of before attempting any questions is the quadratic formula itself. It is shown here, but essentially when you are given a quadratic in the following format, as in ax squared plus bx plus c, you can use the formula to calculate the values of x, which are just the x-intercepts of this quadratic. The letters over here just represent the coefficients, which are the big numbers in front of the x in the equation. So, for example, the coefficient of 5x is just 5. Sometimes the quadratic might not appear exactly like this, but you should be able to rearrange the question so it resembles this format. In this first example here, you can see all the numbers are already positive. This means you do not have to be too wary, but you should be careful regardless, especially when typing this into your calculator. Firstly, you can allocate each number to its coefficient. So a equals 1, b equals 5, and c equals 3. It's a good habit to rewrite the formula yourself to make sure you do not make any silly substitution mistakes. You can then start substituting the values correctly, so it ends up looking like the following. X is equal to minus 5 plus or minus root of 5 squared minus 4 multiplied by 1 multiplied by 3, all divided by 2 times 1. Keep simplifying your equation as much as possible before typing it directly into your calculator. You will eventually get two roots, which are minus 5 plus or minus root 13, all divided by 2. The question asks you to give the solutions to two decimal places, so find out the decimal equivalent of your surds and round appropriately. The correct answers then become minus 0.70 and minus 4.30. The next question is 5x squared is equal to 6x plus 3. This question is not given in the typical format we have seen before in the previous question or the formula. Therefore, we should start rearranging first. After rearranging, you need to allocate each coefficient, in which case a is equal to 5, b is equal to minus 6, and c is equal to minus 3. Remember, they are negative numbers now, as you previously subtracted these terms. Then you follow the same procedure as the last question. In this question, you have to be very careful as some values are negative, so place brackets carefully and make sure to type it properly into your calculator. After simplification, your two roots become 1.58 and minus 0.38 to two decimal places. The next question is a rather long one that requires lots of rearranging before starting. You can see that there are two quadratic equations being equated, so you can easily move terms around to come up with one simple equation to work with. Initially, we started off with 12x squared minus 13x plus 4, which is equal to 13x squared minus 5x plus 1. After rearranging, this becomes x squared plus 8x minus 3. Once again, follow the procedure from the previous questions, write the formula, substitute in the correct numbers, and then type it into your calculator. The question requires you to give your answer to two decimal places. So your final answer comes to minus 8 plus or minus root 76 all over 2, which can be rewritten as minus 4 plus or minus root 19. In terms of decimals, this is 0.36 and minus 0.836 to two decimal places. The next question is a more complex worded problem. It still uses the ideas and steps of a quadratic formula question, but in a contextualized format. The question is, a rectangle field is 15 meters longer than it is wide. The area of the field is 800 meters. Work out the length of the field and give your answer to one decimal place. We don't know the width, hence why we use x to represent it, but we do know that the length is 15 meters longer, therefore it will be x plus 15. Once having drawn an appropriate diagram in which the width is x and the length is x plus 15, you can start working out the value of x and then find the width, which will consequently help you find the value of the length if you need it. You should always attempt to draw a diagram in these scenarios to prevent any misunderstandings. We know that area of a rectangle is equal to base times height, so 800 is equal to x plus 15 multiplied by x. Once you have expanded that, you can see we are closer to a quadratic equation, so then all you have to do is rearrange the equation now. Once you have the equation, you can follow the normal quadratic formula procedures, substituting the coefficients correctly, so a is equal to 1, b is equal to 15, and c is equal to minus 800, and simplify until you have a 15 plus or minus root 3,425 all divided by 2. This means each root is 36.8 and minus 21.8 to one decimal place as indicated by the question. Remember, we just worked out the value of x, which is a length, and lengths cannot be negative. Therefore, your x has to be 36.8 meters. The next question we are doing is a similar worded problem. The diagram shows a six-sided shape formed from two rectangles. All measurements are given in centimeters. The area of the shape is 24 centimeters. Part A says, show that 2x squared plus 7x minus 63 is equal to 0. Firstly, the context sentence of the area tells you that the question is somehow related to the area of the shapes. Although you don't have numbers to work with, you can still work out the areas of the shapes individually. For example, the area of shape 1 is 2x plus 1 multiplied by x minus 3. You will eventually result in a quadratic being 2x squared minus 5x plus 3. Similarly, you can work out the area of shape B and find that it is 12x minus 36. All of this combined area is equal to 24, so equate the areas to 24 and then simplify your quadratic normally. You will result in 2x squared plus 7x minus 63, which is what you needed to prove initially. Now let's move on to part B. Part B says find the value of x. Give your answer to 3 significant figures. This is a simple question because all you need to do is use the quadratic formula to work out the value of x. Substitute the correct coefficients into the quadratic formula and work out the roots of 2x squared plus 7x minus 63. Eventually, you will result in minus 7 plus or minus root 49 plus 504 all divided by 4, which gives you 4.13 and minus 7.63. As x is a length value, the only correct answer is 4.13. Let's try the final question. In this question, we are looking at a right angle triangle. There is some interlinking and a synopsicity in this question because it is linked to another topic, the Pythagoras theorem. For part A, we need to show that x squared minus x minus 14 is correct. From looking at the diagram itself, you can see that there are no square terms, which tells you need to incorporate it somehow, which we can do via the Pythagoras theorem that a squared plus b squared is equal to c squared. Label the sides of the triangle correctly, as in C is always a hypotenuse and A and B can be any alternate side, and then substitute the lengths into the theorem and work out the quadratic. As you can see, there is lots of simplifying to do, so there are lots of opportunities to make mistakes here. Work through this slowly if you try this independently, especially when collecting like terms, and be careful about the plus or minus signs. After simplifying, the quadratic looks like x squared minus x minus 14, which is exactly what you needed to prove in the first place. Now, all you have to do is work out the value of x. Use the simple procedure that we have shown before substituting into the formula and simplifying to find that x equals 4.27 and minus 3.27. It must be 4.27 because x can't be a negative number as it is a length. Thank you for watching. Remember, if you would like further support, we offer one-to-one sessions and group sessions for key stages 1, 2 and 3 along with a specially formulated 11 plus GCSE and A-level lesson. Further information can be accessed on our website at tessonlineschool.com, and if you would like further resources, advice and feedback, please contact us on the following numbers. Thank you.